Before finding the Gauss-Jordan method, we need to see from the basic variables who shall leave and enter. That is, the optimal function, or sorry, the optimal solution should have which all values. So for that we need to find del j. How del j is calculated? Del j is equals to cb into xi minus cj, that is cb column into xi, these all variables. If I am finding out for this value, then I will take these values, this into this plus this into this into this, whole minus this. So here is a summation sign. So 0 into 6 plus 0 into 1, 0 into minus 1, 0 into 0 is equals to 0 minus 5 gives me minus 5. Then again for second column it is 0 into 4, 0 into 2, 0 into 1 plus 0 into 1 minus 4, which gives me minus 4. And similarly if I'll do 0 into 1, 0 into 0 and all, it will come as 0 minus 0, so it is 0, and for the rest also it is 0. Now here we shall select the most negative one, because the variable which is having most negative shall have the highest rate for shall have highest rate in the maximization objective function, like 5 for x1. 5 is greater than 4, so we need to proceed in x1 direction. So after selecting the maximum one, we need to find the minimum ratio. How to find minimum ratio? Minimum ratio is xb divided by whatever is the most negative column. So here x1 will be called as entering variable. This will enter the basis. This basic variable stage is called as the basis. So how to find the minimum ratio? Minimum ratio is xb by the variables of the entering variable. So here 24 divided by 6 is 4. 6 by 1 is 6. This is negative, we won't be considering. This is dividing by 0, we won't be considering. So amongst 4, so between 4 and 6, minimum is 4, which comes from S1 variable. So this one is leaving. Whichever is the minimum one, that is the leaving variable. And here the most negative, we are seeing most negative for the maximization problem. For minimization we shall see the most positive value, and this becomes entering. So in the basis, for basic variables, instead of writing S1, because S1 is leaving and X1 is entering, instead of S1 we will write X1. Then the variables S2, S3 and S4 remain the same. Now Gauss-Jordan method says that this is the row of leaving variable, this is the column of entering variable, this is the row This is the row of entering variables, and this is the column of, sorry, of leaving variables, and this is the column of entering variable. So 6 is my pivot point. Now I need to divide the leaving row by the pivot element. So here it is, this whole row divided by 6. After writing this value, the coefficient in objective function CB values are these. And then for this row, it is 24,641,000 divided by 6. That is 24 by 6 is 4, 6 by 6 is 1, then 4 by 6 is 2 by 3, then 1 by 6, and then 0, 0, 0. That is only for the only for the leaving row. For the other, we need to take whatever coefficient is there for the entering variable column, multiplied with whatever we have found out, and then subtract it from the second row or the whichever row we are finding. That is, here we need to do 612 0100 minus 1 into 4 1 2 by 3 1 by 6, 4 1 2 by 3 1 by 6 0 0 0. So this is 6 minus 4 is 2, 1 minus 1 is 0, 4 by 3, this is minus 1 by 6, this is 1 0 0, and this value needs to be written in the second column, second row, sorry, 2 0, 4 by 3, minus 1 by 6, 1 0 0. Gauss-Jordan method basically does, it makes the entering variable column pivot element as 1 and the rest all values will be 0. When we shall complete this, we will see that. Next is 1 minus 1, 1 0 0 1 0. 1 minus 1 1 0 0 1 0 minus the column coefficient is minus 1, entering variable column coefficient is minus 1, so here I will be multiplying minus 1 to this part which I had written first, the entering row, because this has entered right now, right? So 4 1 2 by 3, 4 1 2 by 3, 1 by 6 0 0 0. This gives me minus minus will be plus. This is 5 0, 5 by 3, 1 by 6 0 1 0, 5 0, 5 by 3, 1 by 6, 0, 1, 0. And then the last mm, and then the last part mm, and then the last row 201, 201, 0, 0, 0, 1 minus column coefficient is 0 multiplied with this, so it's ultimately 0. We will get this as the resultant. So 2, 0 as said earlier before, 0, 0, 0, 1. Now this is my second iteration. Again we need to find del z value. So here del z is CB into respective column will be added minus the coefficient. Here the coefficient of x1 is 5, 4, 0, 0, 0, 0 because these are the slack variables. So it will be 5 minus 5 is 0. 5 into 2 by 3. I am not adding this because ultimately these are zeros. 5 into 2 by 3 is 10 by 3 minus 4 is minus 2 by 3. Then this is 5 by 6 which is positive minus 0. So it's 5 by 6. And then 5 into 0 is these all will be zeros. So here this is the most negative, therefore x2, this is the column for x2. So x2 is the entering variable and the leaving variable will be determined by the minimum ratio. So minimum ratio is xb column divided by the column that is entering. So this is 4 by 2 by 3 which gives me 6. 2 divided by minus, I won't be considering the minus. Then this is 5 divided, sorry, not this one. Then it is 2 divided by 4 by 3 is 3 by 2. Then 5 divided by 5 by 3 is only 3 and this will be 2. So this is the minimum ratio, that is 1.5. So this will be my leaving variable. So this is my leaving variable row. This is my column. 4 by 3 is the pivot element. Therefore again I need to do the Gauss-Jordan method, that is instead of leaving variable I need to write the variable which is entering, that is x2. So it is x1, x2, s3 and s4. Then their coefficients, then CB, well we need to find out. So this is for the pivot row divided by by the pivot element. 2 by 4 by 3 is 3 by 2. So here it is 3 by 2, and then it is 0, 1, 0, 1, minus 1 by 8, then 3 by 4, and then zeros. Then for the other rows we need to write these values, that is 4, 1, 2 by 3, 4, 1, 2 by 3, 1 by 6, and then all zeros, minus what is the coefficient of the entering variable is 2 by 3, is 2 by 3 multiplied with the pivot row that we have written now, that is this thing, 3 by 2, 3 by 2, 0, 1, minus 1 by 8, then 3 by 4, and then 2 zeros. So on subtracting these, we will get here as 3, 0, 0, 3 by 4, 1 by 2, then 0, 0. Similarly, continuing for this, we shall get here 5 by 2, 0, 0, 3 by 8, minus 5 by 4, and then 1, 0. Again here we shall get half, then 0, 0, 1 by 8, minus 3 by 4, and 0, 1. So here again we shall find del z value. Del z is equals to CB into XB minus here we are getting 1, 0, 1 by 4, minus 1 by 2, and 0, 0. And del z we shall multiply 5 minus 5 is 0, then 4 minus 4 is 0, then 5 by 4 minus half is 3 by 4, then minus 5 by 2 plus 3 gives me half, and then both are zeros, because when these two multiplied with zeros or zeros with respective and then subtracting with zeros, we shall get this as the del z value. Here there is no negative term, here everything is greater than or equal to 0. Therefore we can say that the simplex table has reached the optimal solution. Therefore we can find z to be this multiplication and sum of these two columns. So it is 5 into 3, 15, plus 4 into 3 by 2, which gives me 21. So the value of simplex, so the optimal solution of the Reddy Mikks problem is z equals to 21 when we shall see the basic variables when x1 is equals to 3. This is the xb or the solution column. When x1 equals to 3, x2 equals to 3 by 2, this is my main solution. Along with that, we have some slack variables s3 and s4, which are equals to 5 by 2 and half respectively. So this is my final problem of Reddy Mikks optimization problem, maximization problem, where z or profit is maximized to give us the value 21, and the value of x1, that is amount of exterior paint that we will produce, is 3 tons, and this is 3 by 2 or 1.5 tons. And these two values tell that S1 equals to 0 and S2 equals to 0. This means there are no slack variables left, or all the amount is used. Whereas these two tells that these amounts are still left abundant, and this is all used up.